All right, guys. So 7A gets us starting off a new topic, probability. And it's kind of an introduction, lots of things that you've seen before, but lots of reminders. In fact, a lot of this stuff I've taught in 7th grade. So it's something that goes back quite a ways, and you may have not seen a lot of it the last few years, although you should have. It gets skipped over by a lot of teachers, although it happens to be one of my favorite areas of math, just because you can apply it to things that are going on in the real world. So fundamentals of probability. So we've got an example up here where someone flipped 2 coins and you've got different outcomes and different events. So probability really boils down to what are the chances of something happening, okay, in layman terms. And we look at 2 different outcomes. One of those, or two different possible ways we can look at probability. One of those is the outcomes, and one of those are the events. So the outcomes, if I were to flip 2 coins, the different outcomes would be getting like tails and tails. The first coin of tails, the second coin of heads. The first coin of heads, the second coin of tails, or both of them being heads. So my different outcomes would be tails, 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 heads, heads, tails, or heads, heads. But the different events that could happen, if I just wanted to know how many heads or the probability of the different events that could happen, well, if I'm only interested in the number of heads, I could get 0 heads if I had both tails. I could get 1 if the second coin was a heads. I could get 1 if the first coin was a heads, or I could get 2 if both of them landed on heads. So my events, my possible events, are either getting 0 heads, 1 heads, or 2 heads. If I was interested in the number of heads, not all the different possible outcomes. Okay. So just be careful when it's asking for outcome or event. Usually we're looking at outcome. And it's pretty clear when it wants just to know the event. So for example, consider families with 2 children. List all the possible outcomes for the birth order of boys and girls. So first of all the possible outcomes. Well, I could have a boy first and then another boy. Or I could have a boy and then I could have a girl. Or my first child could be a girl and then I could have a boy. Oops, let's get rid of that. Or I could have a girl and then I could have another girl, right? Those are the different possible outcomes. Now, if I'm only interested in the total number of boys, what are the different possible events that could happen? Well, here I've got 2 boys. Here I've got 1 boy, 0 boys. So the different possibilities, if I'm only interested in numbers of boys, would be 0, 1, or 2. So these are my outcomes. These would be my different events if I'm only interested in the number of boys. All right, moving on. We usually express probability as a fraction or a decimal, and we try not to round if we don't have to. We try to get exact numbers if at all possible. But the way that you'll see this written a lot, the probability of an event is expressed as P and then event in parentheses. So this would be like, what's the probability of getting tails? What's the probability of getting diamond if I'm drawing cards? What's the probability of getting in a crash, right? So the probability, the P on the outside stands for probability. The thing on the inside is the event that we're evaluating. Now, this value always comes between 0 and 1. You can't have 120% chance of something happening. Something can be guaranteed to happen. Like if I flip a coin, I'm guaranteed to get heads or tails. I mean, theoretically, I guess it could land on the edge, but I don't think I've ever seen that happen because of gravity and rotation and physics. But the probability of getting heads or tails is 100%. You can't say I'm 150% going to get heads or tails. It's either 0, in between, or it's the 100%. Okay. So usually we like it as a fraction. If you can't write it as an exact fraction or decimal, round, we'll usually go with 3 significant digits. And when you write these, on top is the number of times it could happen over the number of possibilities. Okay. So on top is going to be the number of times it can happen, and on the bottom is the number of different things that could happen. And that's how you'll usually set them up. And again, we've been doing this, guys, you've been doing it for a long time. So one of the first types of probability is a theoretical probability, where you look at the theory of what should happen. So to do this, and this is what you've done most of the time, you count the total number of possible outcomes. That goes on the bottom. And on top is the number of ways that the thing you're interested in can happen. So the number of ways it can happen goes on top. The number of things that can happen, the total possible things, goes on the bottom. So example 2, apply the theoretical method. What's the probability of getting 1 heads when you toss 2 coins? So I could possibly get heads and heads, or I could get heads and tails, or I could get tails and heads, or I could get tails and tails. So there are 4 different possible outcomes. And if I want to know the probability of 1 heads, that's 2 different ways that can happen. So I have a 1/2 or a 50% or a 0.5 chance of that happening. All of those are different ways to say the same thing. Okay, how about getting a 3 when you roll a 6-sided die? Well, there's 6 different sides, and only one of them is a 3. So I've got 1 out of 6 chances, which isn't a nice decimal. What is that? 0.166666 forever. So you would round that to 0.167, or 16.6 or 16.7%. We'd probably make that a 7. All the same thing, okay? All right, playing card possibilities. Now, I put this on here, the example of the cards, because we just kind of make an assumption that you know a lot, or at least enough about cards, you know what's in the deck. But not a lot of people do. But I'm going to tell you right now, it's almost guaranteed that a question involving cards is going to come up. So this is information that you definitely need to know. There are 52 total cards. So if I added all of these together, there's 52 of them. Now, I've got 4 different types of cards. You've got hearts, diamonds, spades, and clubs. Hearts and diamonds are red. Spades and clubs are black. So out of those 52, I've got 13 hearts, 13 diamonds, 13 spades, 13 clubs. I have 26 red cards, and I have 26 black cards. Now, if you look at the cards themselves, all of these have a 2 through 10, and then a jack, queen, king, king, ace. So there are 4 different 2s, 2 red ones, 2 black ones. There's 4 different aces, 2 red ones, 2 black ones. And just information that you might want to know. So if you haven't used cards or played cards enough to know that, write that down somewhere, because you're going to need to use it. All right. So this question, example 3, says that if you draw 1 card at random from a standard deck, what's the probability that you get a spade? Well, total, there's 52 cards. 13 of them are spades, and that simplifies to 1/4 or 0.25 or 25%. I like the 1/4. I've got a 1/4 chance of getting a spade. Okay, 1 in 4 chances. If I wanted to know the probability of getting red, well, there's 26 reds out of 52 cards, so that's a 1/2 or 0.5. What's the probability of getting an ace? Well, there's 4 aces out of 52 cards, which is 1 out of 13 chances of getting an ace. If it asked, what's the probability of getting a face card? Well, jacks, queens, kings, and aces are our face cards, and there's 4 of each in all 4 groups. So there's 16 face cards out of 52 cards. So what's that going to become? 8 out of 26, and then 4 out of 13. So you got 4 out of 13 chances of getting a face card when you're drawing a random card. Okay. 2 girls and a boy. What's the probability that a randomly selected family with 3 children has 2 girls and 1 boy? Assume that boys and girls are equally likely, which theoretically, the third child, if you've had 2 in a row of the same, the chances that the third is going to be the same is actually super high. At least that's the theory I've heard. So we're looking for the total number of possibilities. Now, I don't want to list all of these. I don't want to say boy, 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 girl, boy, boy. I don't want to list all of them out. So I can use the counting principle. My first child, I've got 2 different possibilities. My second child, I have 2 possibilities. My third child, I have 2 possibilities. So 2 times 2 times 8, or 2 times 2 times 2 is 8. That tells me my total different possibilities. And it wants to know, what are the chances of getting 2 girls and 1 boy? Well, I can have girl, girl, boy, or I can have girl, boy, girl, or I can have boy, girl, girl. I think that's the only ways that I can get 2 girls and 1 boy. So that's 3 out of the 8 possibilities that I'm going to get 2 girls and a boy. The order doesn't matter. It just matters that I get 2 girls and a boy. So 3 out of 8. You could have listed all of them if you wanted to, but remember that fundamental counting principle. So and this goes back again to stuff that you learned in 7th grade. Like if you're making a sandwich and you have 4 choices of bread and you have 5 choices of cheese and 3 choices of meat and 6 choices of vegetables, and you get to choose one of each, well, you've got 4 choices of bread times 5 types of cheese times 3 types of meat times 6 types of vegetables. So you would do 4 times 5 times 3 times 6, which is 360. So there's 360 different possible sandwiches you could make if you had one of each. That's that fundamental counting principle. Okay, moving on. Relative frequency. So theoretical probability is what should happen. That's the mathematical theory, what should go on. Relative frequency is where we actually perform the experiment and count how many times something happened out of all of the times that we tried to do it. So instead of the theory, we would take the number of times something happened out of the number of times that we tried. So 500-year flood, example 6. Geological records indicate that a river has crested above a particular high flood level 4 times in the last 2,000 years. So in the last 2,000 years, 4 times we've gotten a flood. So what's the probability that the river will crest above the flood level next year? So I've got a 4 out of 2,000 probability, which is a 1 in 500 probability. And I'm okay with that. I like it written as a fraction. If it wants you to write it as a decimal, you're welcome to do so, but we're okay with fraction answers. So based on what has happened, that's what our probability is that next year is going to be a flood. Okay. Fair coin test. So suppose you toss 2 coins 100 times and you get the following results. 22 times you don't get heads at all. 51 times you get heads once out of the 2 tosses. And 27 times you get heads twice. So it wants us to compare the relative probability to the theoretical. All right, so relative probability of getting 0 heads. Well, 22 out of 100 times that happened, which is 0.22 or 22%. Getting 1 heads, that happened 51 out of 100 times, which is 0.51 or 51%. 2 heads happened 27 out of 100 times, which is 0.27 or 27%. Now, if I compare this to what I would expect to happen, so the theoretical probability, if I flip a coin 100 times, now this is where we don't even need to write it out of 100 times. We can say, all right, if I flip a coin 100 times, theoretically, remember, I can get heads, 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 tails, tails, heads, or tails, tails. So one of those 4 doesn't have any heads at all. So out of 100, if I'm 1 out of 4, that's 25 out of 100, which is 1/4 or 0.25 or 25%. That's pretty close to what actually happened. Not exactly, but it shouldn't be, because this is theoretical, this is actual, but it's pretty close. I can get 1 heads 2 different ways out of 4 possibilities. So that's 1/2 or 0.5 or 50%. So I would expect 50 out of 100 to have 1 heads. And look, I got 51 out of 100. So that's pretty close. And then to get double heads, there's only 1 of those out of 4, which would be 25 out of 100, which is 0.25 or 25%. Again, really close to what actually happened. We're just 2% away. So I would assume that those coins are not unfair because I'm pretty close. Subjective probabilities. Now, these ones are great because this is what happens most of the time. Most of us just throw out probabilities just because we're trying to make a point or we're basing it on our experience. So for example, you could make a subjective estimate of the probability that a friend is going to be married within the next year. If you know your friend breaks up with people a lot and isn't very good at relationships, you're probably going to say there's a low probability of that happening. Not based on data, not based on theory, but based on your experience and intuition about that person. What's your probability that you get a good grade in math class? Well, based on your experience, what are the chances that you're going to get a good grade? That's a subjective probability. And sometimes one method is better than another, right? So example 8 wants us to identify what's better, the theoretical, the relative, or the subjective, okay? I'm certain that you'll be happy with this car. Well, that right there sounds subjective. That doesn't sound driven by data or theory. That just sounds like it's based on their opinion or intuition or experience. Based on housing data, the chance that someone will move to a new residence during the coming year is about 1 in 8. Well, that sounds like relative frequency, that relative probability. Based on what has happened, there's 1 in 8 chances that this is going to happen. The probability of rolling a 7 with a 12-sided die is 1 out of 12. Now that right there is theoretical. In theory, I should roll a 7 1 out of 12 times. That may not happen, but theoretically, that's what should happen, right? Now, the probability of an event not occurring. So it gives us a formula. The probability of something not happening is equal to basically 100% minus the chances that it will happen. That's pretty much it. The probability of it not happening is just 1 minus the probability that it does happen. So what's the probability that a random chosen family with three children does not have 2 girls and 1 boy? Well, we decided like 2 problems ago that there was 3 out of 8 chances that you would have 2 girls and 1 boy. So the chances of that not happening are 1 minus that 3 out of 8, which is just equal to 5 out of 8 chances. You have 5 out of 8 chances of it not happening because you have 3 out of 8 chances that it does happen. All right. So you can take 1 and minus the probability of it not happening, or you can just count the different ways that it doesn't happen. For example, if I wanted to know what's the probability of not rolling an even number, what are the chances of not getting an even number? Well, if I look at a dice, there's 1, 2, 3, 4, 5, 6. I can take 1 minus the probability of getting an even, or I can count how many are not even, which is how I like to do it a lot of the times. Well, that's not even, that is. That's not even, that is. That's not even, that is. Well, there are 3 that are not even out of 6. So I have a 1/2 chance of rolling an even, which is the same as taking 1 minus the probability of getting an even. Either one works. I don't care which one you use, just as long as you understand what it is that's going on, okay? All right, now odds. Here's where we got to be careful because odds and probability are not the same thing. If I say the probability of something is 1 out of 4, that's different than saying the odds of something are 1 out of 4. Those are 2 completely different statements, okay? The odds for an event, the way that we write that, are the probability that it happens divided by the probability that it does not happen. It's not the probability of it happening. It's not the number of it happening over all of them. It's the probability of it happening over it not happening. So your numbers can be very different if you don't read them carefully. The probability, the odds, I almost did it. The odds against an event are given by probability of it not happening on top over the probability of it happening on the bottom. Now, in gambling, I love that this class lets us talk about gambling. When they say the term odds on, that generally means this one, the odds against. Okay? That usually means the odds against something happening. So, what are the odds for getting 2 heads when tossing 2 coins together? So, what are the odds for that happening? So that means I've got to take the probability of it happening divided by the probability of it not happening. Well, the chances of getting 2 heads is 1 out of 4. So the probability of it not happening is 3 out of 4. So I've got to take 1 out of 4 and divide that by 3 out of 4, which gives me 1 in 3. And that's where we say this right here. We don't usually use the words like when we're saying the probability of, we'll usually say like that division line. We'll say something a little bit different when we're talking about odds or probability. Like probability, we'll say 1 out of 4 chances. With odds, you say 1 in 3, okay? So that's a little bit different. That means there's 1 chance of getting it and there's 3 chances of not getting it out of a total of 4. So what are the odds against it? Well, the chance of not getting 2 heads is 3 out of 4. And then the probability of it happening is 1 out of 4. So the odds against this happening are 3 to 1. And a lot of times we write that like this, 3 to 1 or 3 to 1. So if it says odds, just know that the probability is different than the odds. They don't mean the same thing. And to get the total number of chances, because we're dividing them by the same number, if you notice, if I wanted to know my probability was, when I go from 3 to 1, I know that there's 3 chances of it not happening and 1 chance of it happening. So I know that's 4 total chances. So there's 3 of it not and 1 of it happening. So you can figure out what goes on bottom if you're looking for the probability using the odds. So at a horse race, the odds on Blue Moon are given as 7 to 2. So that means the probability that Blue Moon is going to win is on the bottom, and the probability that he's going to lose is on the top. Okay, the odds on Blue Moon means the odds against Blue Moon. So him losing over winning. Now, the way that you figure out bets, and again, I love that this is part of our curriculum. When it says the odds are 7 to 2, what that means is for every $2 that you bet, you could win $7 So for every $2 that you bet, if Blue Moon wins, you get $7. So if I bet $10 on Blue Moon, well, that's $2 5 times. So that means I'm going to win $35. Plus, you get your $10 back that you bet. So you would actually get $45, but you would only be gaining 35. You would get 45 back, but you're gaining 35 because 10 of that you already put into it. So the way that you can figure that out is using, a lot of times we can just break it down into the way that, well, just like we did here. To get from 2 to 10, I times by 5. So I had a times by 5 to get from here to here. So 7 times 5 is 35. That's how I get this 35. Okay, so this leads you on to homework. What are we on? 7A. So homework 7A, you need to be working on that at home if you can. If you don't have time to work on it at home, bring it to class. We are going to go through some of these problems together. You can ask questions, and we'll elaborate on some of this probability stuff just a little bit.